if they click on the Zoom link, then they can access from there. But there's a lot of people from all over the place that they get notified whenever I post something new on YouTube.
Okay.
And because of that, they will probably just be joined in. Zoom link, they can access from there. But there we are. There's a little bit of a delay between YouTube and between the Zoom call here. So it's I got to kind of balance it out. So forgive me if I'm sitting here and like playing around with a bunch of buttons and stuff. So
Yeah.
people are going to be able to ask questions on YouTube, or they can log into the Zoom meeting and they can ask them themselves live, which is also kind of cool. So
Okay.
this has kind of been like a dream of mine for a long time, is to have a series called Ask the Experts. And in doing so, we bring on the engineers that are really responsible for a lot of the things we experience every day. And we have people ask them questions directly, and maybe they get answers, or maybe they make suggestions, for the improvement for all of us, which is also kind of cool.
Yeah, I agree. Absolutely.
Let's see. And I have, so I've got two monitors over here and I've got a laptop over here. So I have redundancy built into almost everything in my life. So let's see, I got to make sure that it's all muted, or else it'll just go crazy. Okay, we got the chat. We got this. Oh, this is gonna be so good.
So I will leave it in your hands to sort out how the questions come in. Are they going to become in written or
So they might ask them,
verbal?
or they might type them in, and either way, we'll figure it out. I do have like several pages worth of stuff. Some of these are things that I've been curious about for a long time, and other ones, I've had a lot of people reach out in, some pretty desolate communities, and they're trying to figure out what they can do for electrical safeties as well. And we do whatever we can to help them. So
Yeah.
definitely some
Yeah.
good information here. Okay.
Oh, I think so. Yeah. I should be quiet and let you figure out all the button pushing.
So yeah, one of the things I got to tell you that I really think is cool, I haven't figured out how to do it myself yet, is on LinkedIn. I know that you have a little sound clip next to your name that tells people how to say your name, which is so cool.
Is that
So
right?
yeah,
I didn't
yeah.
know.
Yeah, on your LinkedIn, it says Matt Beartich, and it's a little auditory cue, and you click it, and it says how to say your name. And I was like, that's so cool. I've got to figure out how to do that, because people ask me all the time, like, what my last name is, and it just makes things way easier.
Yeah. So I'm going to say, is it Barber?
Yes, sir.
All right.
That's it. Okay, so we have what, about 10 minutes? Cool.
Yeah.
All right, I'm going to put this guy over on a pause screen, and then people will log in as they come in, and we shall be good to go in about 8 minutes.
I know what you're saying about, you know, I talk to techs all the time that, you can tell that, they do lots of electrical safety testing and sometimes wonder, what's the point of it all? And am I doing it right? And, everybody wants to keep people safe and follow the regulations, but sometimes they feel like they're kind of on their own in sorting that out.
Oh,
So,
I absolutely agree. And the crazy thing is I honestly don't believe that most people do electrical safeties correctly. And I'm willing to bet my paycheck on that, because it's the craziest thing. And people think I'm joking when I say it, and I'm like, no, I'm dead serious. Like, most people, they either do it out of order, which doesn't make any sense, or they don't do it exactly as it's talked about in NFPA 99. They're missing steps. And even then, there's a whole nother step that we're going to talk about. Whereas if a device has motors, or if it has a heating element, or if it has a fan, if it has anything that is energized, when you're doing your leakage, you have to energize it, or else you're not getting an accurate leakage anyway. So, but that's something that we'll bring up when everybody's on. But
yeah.
yeah, it's
Well,
been crazy. So
Yeah,
I
I think the other message that's starting to get out in a lot of places across the country is that um, we probably don't need to be doing anywhere near as many electrical safety tests as we do, which would, another way to solve that problem
I
is,
would actually agree, and I have been on that for probably the last 3 or 4 years. Is that there's certain things that we do that really do matter, and there's certain things that's just like busy work. And part of the problem is there's so many third-party companies out there. They get paid per PM that they just stack all these PMs on technicians because they know it's easy work, right? But
hmm,
is it necessary? And there's other things that we could be doing. And it's interesting because I read through some of your posts and stuff, and I think we agree on a lot of this stuff. Is that there's a certain ethic that we need to have. Like when you have an entire fleet of equipment, if you experience a problem on one device, you need to go through the rest of your fleet and check those ones because it's probably manifesting someplace else. And
hmm,
I mean, when it comes to like electrical hazards, there's so many other areas where we could solve the problem. And we'll get into it all on when the stream gets wide. But I've got a history of doing unofficial forensics after an incident and stuff, which is super cool that you're a forensic analyst because once you figure out how a problem happens, now you can keep it from happening someplace else,
that's right.
which is
That,
probably more important. It's the most important lesson you can have
yep,
is prevention. So
yep, that's the point. That's the point. We can learn. We can get
absolutely.
smarter.
Let's see. Okay, let's cancel that. We are good. Okay, my Zoom is giving me little prompts and stuff. Man, this is gonna be so good. And I have definitely had my coffee this morning, so I've got young kids and they wake me up really early, so
Yeah,
I have to get up and get going like first thing in the morning.
I know what you mean. I don't have young kids anymore, but I've got in the habit of getting up early and getting stuff done when the day is still a little bit quiet.
Yeah, I think pretty much anything after noon is pretty much just finishing up for the day because that's when I refer back to my customers and whatnot in communication. And that's when I respond to emails, if not first thing in the morning. And, if I order parts and stuff, that's when I do all that follow up is afternoon. And then the next morning I hit it hard again, like first thing.
Yep.
So I wish I had a mouse that could go from this display to this display and straight over here. Cause now I gotta like, I've
Oh,
got, yeah, it
that's
gets a little
that's
confusing.
that
So
is confusing.
I have multiple monitors. This monitor over here is how I control my studio. So I can do things like this where I can
Hmm.
control my cameras. I got multiple cameras. Um, let's see. Yeah, so I can even pop over and here and right there. Okay.
Yep. Yeah.
So
Good.
yeah, I have a lot of things kind of set up pre-configured so I can flip through them pretty quickly. And over on this computer is where I can stay up on people's chat. Perfect. Here we go. Okay, let me post a link.
I'm gonna let you monitor the YouTube in case the questions come up there.
Okay. Yeah,
So,
there's a like a 40-second delay and they can be very distracting, between
yeah.
here and here.
So if you see a question over there, just read it out and we'll talk about it.
Sure thing. I think hopefully I encompass a lot of the things that have been asked to me. So I get emails from pretty much all over the world. And one of the interesting things is, like I said earlier, a lot of people utilize us as kind of the standard because they don't have a written standard that they know of. And most of those people don't even have electrical engineering backgrounds or biomedical schooling. It's fascinating that they can still make do. I mean, I've had
Yeah,
doctors over in like Ukraine during the war, like asking questions about like, hey, is it supposed to be doing this? Or I've had people in remote areas like Ethiopia, South America, middle of the night, like helping people out with questions and whatnot. But this is always kind of what I wanted to do is instead of me answering the questions, we actually get it on record, and then YouTube saves it and archives it. So whenever somebody Googles it, this video is going to pop up like top of the line, and then they can get their answers direct, and we're good. So
yeah,
that's been the goal.
yeah. A lot of the things I've written over the years have been because I got asked questions so many times and I had to give the same answer over and over. I thought, I'm just going to write it down. And then the next time I get asked, I'll just send them a copy, if it's a little article.
Well, that is actually how I got started in YouTube, is because I was always training people. And since I was always training people, I was repeating myself. And I honestly feel like biomeds in general need to have annual training, like core competency training. Things like electrical safety should be something that we get signed off on every single year. And
Mm-hmm.
that bloodborne pathogens, HIPAA, all the stuff that we do, but there are core competencies that are relevant just to us, and we should be signed off on it. I mean, whether you've been doing this 20 some years like me or 1 year, we should all be treated the same because, as we're going to talk about today, electrical safety standards do change, even though it's been stagnant for a while. I mean, I got in this career field back in 2003, and since then, the electrical standards changed multiple times, and it's actually kind of wild. And we're going to go into that because one of my future videos is going to be called The Generations of Electronics,
Mm-hmm.
because there are generations like AC only, then AC with DC controls, and then, DC with computers inside. And then the latest is going to be, the Internet of Things type of devices that won't physically operate unless they're connected to, a data pathway someplace. So I have a video. I just need examples of each piece of tech in order to finish it.
Yeah.
And it's also going to be what we're going to talk about today is why I believe electronics have gotten incredibly safe. So, I mean, compared to where they were even 20 years ago when I got started, now, because everything is pretty much isolated, double insulated, or they use switch mode power supplies, pretty much everything today has minimal leakage. It's not directly connected to mains anyway. And,
Right.
liability, they all have like overcurrent protection and stuff. It's wild. So
Yeah, absolutely.
anyway,
Yeah.
guys, it is noon for me. And that means it is go time, everyone. So thank you very much. If you guys are watching, you can either watch from Zoom here, or I do have this playing on YouTube. If you guys want to reference this video in the future, you're absolutely welcome to go over to YouTube at any time. You can Google it, look on my channel under the live stream. You'll see this video pop up. And I might actually take excerpts from this video and make little shorts going forward on just some core principles that we're going to discuss today, because this is the pinnacle of our career field is electrical safety, keeping people safe. And that is why I'm being joined today by Matt Baratek, who is a PhD, and he literally wrote the book on electrical safeties in hospitals. And he's been a pillar of the community for many years. Sir, I looked back and you were a director of operations when I was born in 1980.
Yeah, that puts a mile marker out there.
Yeah, but so I mean, you have been around since the early days before the 1980s when we really kind of came up with electrical safety, and now I mean here we are today with some incredibly modern equipment. We're going to talk about risk factors. We're going to talk about electrical safeties, regulations. We're going to talk about a lot of things today, so stay tuned. I'm going to try and put little timestamps in the video so that you guys can keep track and easily reference this in the future. So, Dr. Baratic, thank you very much for being here today. We can finally get these questions answered. If you want to go ahead and tell us a little bit about yourself, we'd love to hear it.
Oh, sure. Well, thanks for the invitation, Justin. And call me Matt. I've been in the field for a long time. I got my master's degree in 1977. So I sort of start my career clock back then, and have seen some of the things you and I have just been chatting about. Changes in technology over the last several decades. So I'm a clinical engineer. And I have sort of done two areas of practice. One is in operations, HTM operations in healthcare facilities, and also as a consultant helping hospitals do that with my company, Baratic Engineering, which is based in Colorado. And I also do forensic engineering. So I do incident investigations where there's a suspicion that a medical device may have contributed to an adverse patient incident. So I work with risk managers and with attorneys in many cases on analyzing that kind of problem. So that's been my consulting work for quite a while. Right now, I've got a new hat that I've been wearing for the last couple of years. I work for actually employee of a group called Lower Mainland Biomedical Engineering in Vancouver, British Columbia. And my job for them right now is that the entire province of British Columbia uses a single CMMS software package. And we have decided a year ago that we wanted to replace that. So I'm leading a project for swapping out the CMMS for the province. So I get to do a lot of different interesting things. And one of the things along the way was some stuff about electrical safety. So always glad to talk about it.
Absolutely. Well, I'm going to go ahead and flip this over so that y'all can see we actually have the book, and it's available on the Amy website. If you guys are interested in taking a look, I'll also have a link for it down below the video after we're finished with production, and you guys can take a look at it. I think it's going to be pretty interesting because the NFPA 99, which is the document we're going to talk about today, is very complex. It's exceedingly complex, and what's even crazier is that it changes every 3 years, and in such, it makes it very difficult for the average everyday person to stay up to date. And that's why this is so exciting. So first off, Matt, I just mentioned the NFPA 99. Could you please tell us about the NFPA 99? And I know like a lot of electrical safety got started around the 1980s with Ralph Nader and whatnot. And if you can tell us about what has been going on in this industry, because we're all just kind of thrown into it and we're trying to understand what is electrical safety and why is it that it's changing?
Yeah, well, that gives me a chance to show this picture, which is the Ladies' Home Journal from March of 1971, where Ralph Nader wrote his article called Ralph Nader's Most Shocking Expose. And he was saying that there were thousands of people who died from electrical shocks in U.S. hospitals, and which, of course, we know and has been disproven since then. But it really was the start of a lot of the concern here. So, and also want to mention you flashed up a picture of the electrical safety manual, and it's not that big of a book, but Amy asked me to write that because to collect things. So that manual pulls material from NFPA 99, which I'll talk about in a second, and NFPA 70, which is the National Electric Code, and some other NFP standards from some IEC, International Electrotechnical Commission standards. So the idea was people didn't need to buy all of those uh, books and pull out just the little pieces about electrical safety. So we pulled them together in one spot, and that was the intent. It's a 2015 document, but in terms of electrical safety testing standards that we're responsible for, things haven't changed since 2012. So what's in that book is still accurate and relevant. And I think the most important piece is NFPA 99, and that is a code called um, uh, healthcare facilities, and it's about all sorts of things about maintaining healthcare facilities, including um, uh, emergency management, power distribution systems, emergency generators, and a whole bunch of things. And there's one chapter about equipment that has the electrical safety material in it. And the reason why NFPA 99 is so important is that in 2012, quite a few years ago now, the Centers for Medicare and Medicaid Services, the federal agency that pays a lot of money to hospitals. A lot of hospitals get their money from from CMS. And CMS in 2012 said, we will follow the 2012 edition of NFPA 99. So that's our Bible for the next while. And there have been, as you said, every 3 years, NFPA 99 gets updated, but the electrical safety stuff has not changed since 2012. So it's still sort of the standard that we work by. And so I think a lot of what we'll talk about today is about what it requires.
Excellent. I've got some people that are asking questions on YouTube. And folks, if you're watching on the Zoom workplace, on your Zoom meeting, if you want to chime in and ask an auditory question, you can go ahead and do that, or you can type them in the chat. I'll be reading them off if I see anything pop up in the chat. But Matt, why has the NFPA 99 been getting more lenient? In many areas, it seems like they're getting more lenient on what some of the standards were. Because when I got started 20 years ago, it was very direct, very stringent. What do you think?
Yeah, so there was quite a change going from earlier editions to 2012. And as I was saying, since 2012, it really hasn't changed in terms of electrical safety, but it's based on evidence. You know, the idea that 10,000, what did Nader call it? Hospitals are electrical safety horror chambers for, and of course they're not, and we've learned that since. And so it's accumulating evidence that says we can keep people safe and spend less time doing electrical safety, and it frees us up to do other things. I don't think there's anybody in this business who doesn't wish they had more time to do other stuff. And when you're doing your 100th ESP of the day, you could think, if I could cut this back, I could actually go talk to the nurses. I could go look into some problems and maybe head off some problems. So I think it's all a good thing that we're actually becoming more evidence-based, data-based in what we do.
That's a good point. Now, I've had several conversations with Vincent Wang, who, if you guys don't know, he's in charge of the clinical engineering aspect of Sodexo, and a very, very smart gentleman too. And he has referenced a couple paragraphs in there which they refer to the fact that you don't necessarily have to document something if it's outside of regular operating realm. So if it's operating as normal, you shouldn't have to document it at all. And that's actually written in the NFPA 99. Why do you think it is that we just continue to put maybe too much documentation in some of our work orders?
Yeah, I talk to people a lot about that. Some people will say, I record the leakage current, for example, And then because then I can look back, over previous years and see a trend. And when I quiz them and say, well, when is the last time you actually did that? I mean, who goes back and looks at their old EST results? Uh, so, if you really think you can do that, or you want to do that, that's fine. But typically, you don't find that sort of degradation and you don't really care about it until it's over the limit. So just keep screening it, and when you see that it's out of limits, then take action. So NFPA just 99 just doesn't require it, and I think that's another example of how over time it's a large committee that meets to update any of the NFPA standards, and they come through a consensus process and a public comment process, and they're the ones who do all that deep research for us to say, it's not worth doing.
Interesting. So we're talking about risk factors, and a lot of places are moving into AEM programs, which is alternate equipment maintenance programs, I believe is what it stands for.
Yeah.
Well, I've got a video that I'm going to be coming out with, and it's been in the works for a while, and I talk about the generations of electronics because, in my opinion, electronics have gotten exponentially safer over the years, and that's because we have efficiency improvements like switch mode power supplies, and now a lot of things just operate off a battery, even patient monitors. I got one right here. It's got a DC jack input, and they have external switch mode power supply, and that means it's double insulated. We're at that day and age where it seems like a lot of electrical safeties are just maybe some CYA, and maybe people are stacking PMs to prove that they're doing work to justify their job. I don't know. We have plenty of work to do out there for sure. But I've got an evolution in my mind of electronics. Since you've gotten started back in the 70s, what do you see that looking like when it comes to medical electronics? Because I remember like we used to have a lot of things that were powered by AC directly, like motors and stuff. And nowadays we have like pulse width modulation, brushless motors and stuff. What do you think about that?
Oh yeah, well, there's been a lot of change. That's an important example, particularly in terms of the electrical power. I mean, things take less power. You could say too. I mean, whether it's the displays take a lot less than a huge CRT.
That's true.
So there are those changes. The other change that I've really seen over time is that when I was early in my career, the focus, the sort of where we are thinking was on discrete components. Like I can remember digging into a patient monitor and identifying which transistor had failed, and then unsoldering it and putting a new one back in and testing it after. So that was sort of the focus of the kind of things that we did. So we've gone, from that to maybe board swapping to swap, and we are up to the point where the device, so many devices are connected to the network. And as soon as you have devices talking to each other, you have to stop. We don't need to think about individual transistors. We need to think about the system. So how does this medical device fit in and interact with other parts of the technology? So that to me is one of the biggest things, and it brings along different things. So maybe I don't know. This would be a question for you, whether you still need to know how to solder, but you certainly do need to know some things about how devices connect to the network. And that's a real shift in the knowledge base for people like yourself who do that work.
I completely agree. It's kind of crazy because I can't count how many times I've actually saved the day by being able to solve something like mid case or whatnot. I specialize in surgical, and there's a lot of stuff that would happen mid case, and I solve those problems. But right from the beginning, I mean, rudimentary soldering and stuff, yeah, but like the amount of equipment, time, knowledge, and experience it takes to do like surface mount is just incredible. And that's why you already talked about us doing board swaps. And there's a negative connotation on that, all we do is swap boards. Well, that's because the board is inspected and treated as an entity, and then it's a proven part that is installed, so it doesn't take the whole system down. It is a different line of thinking compared to back then, but nonetheless, I do have I've got a couple questions here that are just kind of eating away at me.
Yeah,
In
go
the
for it.
NFPA 99, I've got there's a direct methodology to how to perform an electrical safety. It goes step by step, and it tells you how to do it. And I'm just curious. I tell people all the time that it seems like nobody does an electrical safety the correct way. It tells you what order to do it in, and even if they do it in the correct order, there's a lot of devices out there that have ancillary things like motors, heating elements, irrigation motors. There's a lot of things that if you're not running it while that is powered on, then you're not getting a true electrical safety anyway. Now, I think that a lot of people don't do electrical safeties correctly anyway. What do you think about it?
Mm. Yeah, I think there's a lot in what you said. That the thing I see that really is definitely not an appropriate thing. You can't do an electrical safety test on a good one on a device that's connected to an isolated power system, which you might encounter in an operating room. So you have to deal with that. With regard to the order in which you do it, I I don't know. I'd have to do some testing to see how that works out. But there's an analogy that I like to point out. So if there's a health fair at our healthcare facility and you can go in and you get a finger stick and one drop of blood, and they analyze it and they tell you if your blood lipids are out of line. Well, that's not actually a very exact test. It's not a very accurate test, but it's quick and it's easy and it's cheap. And so what they do is if, the numbers look haywire, they say, go see your doctor and get a real test. I would say what we're like is we're doing that on screening for electrical safety problems. So we don't have to reproduce exactly what the manufacturer's quality assurance process would be. We're doing something that's cost effective, economical, short period of time, and we do a good test that just says, oops, this one is over the limit. I need to dig in further. So I think it makes good sense to have a standard way that you do your electrical safety testing, the different pieces of it. But I'm more concerned that all of the pieces get done, and I don't know whether the order is as important as just getting it done in a timely fashion.
Okay. So I'm of the opinion that biomed technicians need to have regular core competencies like nurses do. They're
Mm.
tested on things pretty regularly. And I'm pretty certain that electrical safety is one of them because I always see people doing it wrong. That's the last question.
Yeah.
What do you think about implementing some sort of core competency training into a regular biomed curriculum?
Oh, into the curriculum or on a
Or
recurring basis?
well, every year, if you work in a hospital, you have a regular training curriculum anyway. You're going to have like bloodborne pathogen, you're going to have HIPAA
Yeah.
training. And I think that we need to have special training that should happen every single year because some people forget and, just to let you know what the standards are.
Yeah, I think that's reasonable to do because those well, you're saying you've been in the field for 20 some years. I suspect that you forgot a few things. I certainly know I forgot a few things over the years. So um, staying up to date on things makes really good sense. I don't think it needs to be a real in depth on every
Right.
topic, but some overview kinds of things, particularly about any changes that have occurred. That's the thing that I've seen is that I will ask people, why are you doing that? And they say, well, and it's some version of, well, that's the way I always did it. And they didn't get the memo that the requirements have changed. And so um, letting people know about the latest information, I think, is absolutely important.
I absolutely agree. And one of those changes that's been happening across the entire industry has been AEM programs. We mentioned it earlier. Can you tell us about AEM programs and what somebody might want to do to try and implement something like that? Because there is a lot of work that we have to do, and it's not getting less by any means. So, what do you think?
Yeah, absolutely. We should have a whole session on AEM, Justin.
Oh boy.
Um, but yeah, AEM, it's an alternative equipment maintenance. So what alternative to what? It's an alternative to what the manufacturer recommends. And CMS and the Joint Commission and the other accrediting organizations say that's okay as long as it's a data-driven process. And let's just stop doing. I keep threatening to get a T-shirt that reads "Stop doing stupid stuff." I mean, there's a lot of stupid things that we do that there's no reason to do it. We could simplify, and so, but we don't do it just like because Matt or Justin said it was stupid. We do it because we have some disciplined process where we figure that out and we document it, and we also have some kind of a backstop. In other words, we have a metric to see, if I decided I'm going to change a battery less often than the manufacturer recommends, I want to watch that and make sure I don't get a bunch of new battery failures down the road. So there needs to be some kind of a way to catch, review whether we made good decisions or not. So there's a process. Early on, I mean, AEM's been around for like 15 years now. And so early on, the surveyors would come in and if you said, I do AEM, I don't follow manufacturer's recommendations, they would look at you critically. But now, for quite a few years now, Joint Commission surveyor comes in and says, do you have an AEM program? You say no. They'd say, why not?
Yep.
Because it's the way to do it, to responsibly cut down our workload so we can do other things with our time. And so it's you just have to have a careful process for doing it. And there are resources out there to figure that out. And I think a lot of organizations are a lot of hospitals I talk to have implemented those. It's a little harder, I would guess, if you're some kind of a shared service or commercial company, because you've basically you've got to do what the customer wants.
Right.
But I
Correct.
think understanding the AEM principles is an important one, which is why we should have another one of these sessions.
Yeah, that's no, I'm actually very interested because I get a lot of questions on that. And there's a lot of biomeds out there that they're the only person at their entire facility and they're running around checking like thermometers and stuff. And the whole time I'm like, guys, there's so much more important stuff that we should be doing. And if you guys haven't caught it in the pre-show, when we were talking, it's going to be streamed live, and you can catch it there. We were actually talking about how that a lot of people waste time and energy, and the fact that risk is such an important piece of what we do now. And go ahead and check it out. I agree. We should definitely have a whole nother show on AEM because a lot of people are asking how do they implement something like that. And I know Amy has several documents about it. I don't have the link for them right here. I know I should, but it is a regular structured risk assessment program. You have to have the data to back it up, and then you have to have the hospital staff sign off on it that this is okay.
Yeah.
And so
Yeah, there's a publication out there now from 2018 that actually I wrote and at their request. And but they're brand new. What's happened is that Amy just released EQ 103, which is an actual standard about AEM programs. So that's out there. Just came out middle of last month. It finally got released.
interesting.
And they have just approved a committee to take on what they call a TIR, Technical Information Report. So it's not an official standard. It's sort of it's recommendations about how to comply with the standard. And
Okay.
so there's going to be a TIR on AEM programs coming up. So it's still a hot topic.
Understood. I'm actually gonna I wrote it down, so sorry if I'm looking down. I'm writing notes because I love following up on this stuff, and I'm gonna read that, and
Yeah.
I'm going to see maybe invite you back and we can do another show on it because I honestly do think that this could help a lot of people out.
Yeah.
Now, one of the things you mentioned earlier is testing electronics inside an isolated power environment. So I'm a firm believer that probably a lot of people aren't doing that correctly either. How do you think somebody should normally test equipment that's inside an
Mm,
operating room environment, and when should they test it, to be honest?
yeah. Well, I think that when to test it is just part of whatever your policies are about how often that device needs to be tested. So there's not the number doesn't change whether it's inside or outside isolated power.
Okay.
But so the options for testing something are, if it's something you can take out in the hallway and plug it in, that's one way to do the testing. You can run an extension cord out into the hallway and power it up if it's something you can't move around like the OR table. And the other option is you can plug it into an isolated power transformer, isolation transformer, I should say, and do your testing then. So those
Okay.
are really the only options. But oh, we could have another talk about isolated power systems, but they're really very different, and so they give the numbers you would get if you test a device inside in an isolated power system in an operating room, for example, will be
Correct.
quite different from what you get out in the hallway. So there's some good material for any of the listeners who have access to ECRI subscriptions. They have some good stuff about isolated power and electrical safety testing and so on. So that's a worthwhile resource if you can tap into that.
Interesting. I didn't even know about that. I
Yeah,
will definitely ask to see if I can get access to that to try that out. Because I've always run an electrical cord in and hook your electrical safety analyzer up to that and then power the device off the safety analyzer. That can be pretty cumbersome, and in some places you might not even have power like going down the hallway for quite a ways. So it's
yeah,
constant challenge for us, but
yeah, not ideal, but
yeah,
I,
people
you
should
know,
know that it's just not going to give you accurate results if you test locally inside an isolated power operating room. That's the summary.
yeah, that's right.
So we have a question here. It says, how do we test ventilators, for example, as they have batteries also? Do you have to test it without the battery and then with it alone? How should they test that?
I would just test it, fully assembled how it's normally used.
Yeah, because battery charge circuits are going to generate some leakage, but most importantly, if you're testing a ventilator, you should be testing it while it's doing something, right? Because if you're testing it without the battery, it's not going to be doing anything. So you got to test it with the battery in it, and while it's running, so
Yeah,
it's doing something in order to, get a full function check. And that's one of the things that is actually in the NFPA 99 is that you have to test all functions. Now, I'm currently working with BC Group, and I'm helping them write some of the software on their electrical safety analyzers, because there's one of the features I think that all electrical safety analyzers should have is that's like a pause that allow you to run some functionality of a machine, so it maybe takes a high peak level, because there's certain things you could do that will create a peak, a surge in leakage. But overall, most devices are pretty safe regardless.
yeah.
Uh,
So
I,
NFPA 99 doesn't say a lot about testing function, but Joint Commission certainly does. So that something that has bugged me over the years is people who will say, I'm doing PM on some device. And what do you do? Well, I do electrical safety test. Well, do you do functional testing? And they say, well, no, I don't have the accessories, or I don't know how to do that, or I don't have time for that, or whatever. But the fact is that Joint Commission is saying you want to make sure the thing works, as well as, that it doesn't have some electrical safety problem. Usually the things that cause something to fail, an electrical safety test, are pretty obvious. It's like broken grounds or ground pins,
Hmm.
or some major problem internally. And so, the data would suggest that we should be less worried about whether it's 100 microamps or 110 microamps, than just as long as it's under
Hmm.
the limit, then you're good to go. But all goes back to my analogy about, we're in the screening business. We're not in the manufacturing QA business. And by the way, that's me. That's not a standard. That's just the way I look at things.
No, I agree, and it looks like, we're kind of directed to look at it that way as well. Now, I myself, I've seen well over an amp worth of leakage while a motor was running. That was on a Jackson table, and
That's
I've been lit up before when I touched the heat sinks on a unit because there's a shorted component and it was leaking directly into the ground plane. It lit me up pretty bad. Have
mm,
you've ever been shocked by working on anything?
yes, I have. Yes, I have. And not that long ago, I thought I was getting too old to be doing that stuff, but I did it the other day. Um, so what I find really applicable is a thing called the STAR principle. It's like an acronym, STAR. And I don't know who came up with this, but for me, STR means shoot, that ain't right. And so when you see something like that, something that's too hot, something that has a funny sound, something that that is some spike, ridiculous high um, leakage current. Those are That's where our professional judgment, our experience comes in and says, "Shoot, that ain't right." So let's dig into it. And
That's right.
I think that's really where we bring our professional value to the profession, the
One of the
professional
things that I've
judgment.
been teaching people for years is that if you experience an anomaly or if you see it, if it happens to one, it happens to more. That's one of my rules of repair. And I'm of the belief that you should go and inspect part of your fleet at least to see if it's a common trend, because it's often, you know, staff, maybe it's frequency of usage. It might have a really high usage rate. Sometimes it's facilities might even have like bumpy floors and stuff, or stuff just gets loose and stuff happens, you know. But if there's a tech that experiences something that's not normal, it's a suspect device. What do you think the tech should do if that device is currently in use?
In use meaning not on a patient, but it's out on the floor to be
Yeah,
available to use. Yeah.
correct.
Well, I think if it looks like a safety hazard, you've got to take it out of service. I
Mhm.
mean, if it's the only one that they've got and somebody's dying unless they use it, of course, emergencies trump whatever you've discovered. But yeah, you've got to deal with that.
So you,
Some of those things that you were suggesting, indicate that there's something serious going on, and it could
I've
hurt
had like
somebody.
limb panels alarming and stuff like that, you know, and I've been in the instance where you couldn't remove it from service because it was currently hooked up to somebody. And it's, I mean, every happening has got to be treated as a separate instance. But I mean, technicians are often very confused on what they should do, and I'm of the same frame of mind that you have to remove it from service. If that means that the patient has to be put on hold and they got to bag a patient or something for the moment, which I've seen where, anesthesia machines start smoking and whatnot. I've seen it. You gotta get it out of there, regardless of what the doc says. You got to be adamant and hold your ground. But I have a couple other questions here.
Yeah.
So, pertaining to that ventilator question, it says, so what happens with reverse polarity? Is the battery supplying power?
Oh,
Battery
interesting.
doesn't really have anything to do with reverse polarity because hopefully you're never reversing the polarity on a battery. But what do you think about reverse polarity testing for medical equipment?
Yeah, that's a good one. So in the 2012 edition of NFPA 99, it went away.
Hmm.
And I would say that the reason is that so reverse polarity testing maybe makes sense as a design criterion for the manufacturer to make sure that if this device somehow encounters a wall outlet that's miswired, that it's not going to cause some serious problem. Fact is, in the day to day, when a wall outlet is installed, it's typically done right. It's tested, and some outlets are tested periodically according to codes and standards. And they don't like magically swap their polarity. You know, the wires don't jump from one terminal to another. So what's behind it is the sense that it's just not worth taking time to test something on reverse polarity because it's so unlikely that the device is going to encounter that. So that's an example of what we were chatting about earlier, Justin, is that you can um, we just need we've simplified some of the things in electrical safety testing, and we've gotten rid of some of the lead leakage tests. We've
Hmm.
got rid of some of the things that are just not are just time wasters.
Well, part of the reason this conversation actually is taking place is because I was of a pretty firm belief, and it's probably an old school belief, that there's two times when you should write down your electrical safety results. And my belief is that when something first comes into the building, should have some sort of record of it, and after a repair, because technicians create problems. It's pretty often. But I mean, obviously, that's going to be it's according to FPA 99. That's not necessarily the case. It's not necessary. So,
Yeah,
what do you think?
but well, you brought up a really important point. Another really, really big change in the 2012 edition was the following. It used to say before that, it used to say you did electrical safety testing when you put it into service,
Correct.
and that's still there because it turns out the data show a lot of electrical safety failures show up out of the box. And for some reason, they got damaged in shipment or they got through the manufacturer screening process or who knows. But quite a few things do come through. And that's a good time to write down the numbers, sure. And to when any time that you've done a repair that could have interfered with the electrical safety features of the device. So if you're messing with the power cord or the power plug or power supply or something like that, messing is the wrong word, but working on those parts of it, you should do electrical safety testing after that repair. I would say you do anything that opens the cover. I'm going to do an electrical safety test afterwards because who knows what might have been harmed. It used to have also that you did routine electrical safety testing at regular intervals, and that went away. That's not in NFPA 99 since 2012. And so there's no requirement there to do routine electrical safety testing. And
Interesting.
there are lots of hospitals that have entirely or almost entirely done away with it, except initial and after repair, but not on a routine basis. A lot of places don't like that, are unhappy with that, but a lot of places have done it.
And you, sir, you're a forensic engineer. So that
Yeah,
means like after an incident happens, you're the first person they call to come in and figure out what happened and why did that happen.
yeah.
In your experience, are most of these problems related to like user error, or is it really that the equipment's failing? Like, What do you think is happening most of the time?
Oh, yeah, that's a great question. So this is, I'm taking that as a broader question than just about electrical safety. And what I have found and what I've heard from colleagues that do similar kinds of work that I've been talking to for a long time is that it's actually not that common for the device itself to fail. It could have contributed to a problem, and the way it contributes, sometimes the accessories, foot switches and so on, sometimes the disposables like an infusion pump infusion set are the problem. And but it's usually what now we call use error, meaning something went wrong in how it was used. So it could be misprogramming. It could be because the person didn't know how to program it, but it could be because, it could be all sorts of things. It's hard to program. Some infusion pumps are hard to use. It could
True.
be because the average age of nurses is above 40 and they're into bifocals. And so trying to read an infusion pump in the middle of the night in a dark room makes it damn hard to do it right. So
Okay.
there can be a whole lot of factors that influence whether something ended up being used correctly. So what I've found, just to answer your question more directly, in incident investigations, you do have to think about the actual function of the actual device itself. But there's so many other things in that picture that have to be taken into account to figure out what went wrong.
Correct. And from your experience, how many times have you ever heard of a patient actually getting shocked from equipment?
Mhm. I have been involved in a few incidents where that was the report, and we couldn't find anything wrong with the device. It's possible it was static electricity. There are ways that that could happen, but documented shock is, I haven't encountered it, and the data on it are that it's really, really rare. There are some patients that are so-called electrically susceptible, meaning that for example, let's suppose they have a conductive catheter into their heart
Oh, yeah, yeah.
for pacing, or a catheter with conductive fluid in it, saline fluid into the heart. So there's a direct path for electricity into the cardiac muscle. And so that's why you'll see, higher standards for some kinds of equipment that are used in a place where that might be the case. So it's hard to um, say what exactly happened when someone died in those circumstances. But
Understood.
the data are really limited. Let me turn away for a moment. There is a book that came out in the late 80s, Electrical Safety in the Patient. And it was written by two anesthesiologists who were active in the 70s in this electrical safety scare, who thought there were thousands of people who were being shocked in hospitals. And they set out to write a book about how that came about, what to do about it. And they ended up writing a book that said we couldn't find any. We
Hmm.
could not find any documentation of any, let alone thousands.
Wow.
And so I think it's a really important book where somebody was really invested in thinking one direction, changed their mind almost 180 degrees based on evidence, and that's hard. It's hard once you believe something to change your mind, to
Hmm.
use data, and they did. And so going back there into the late 80s, where they were saying it just ain't there. It's just not that problem. And so that's where we are now in terms of electrical safety testing, saying we've probably been wasting time. Now I'm not telling anybody listening here to not follow their policies in their
Right.
organization, but I would say that people who are responsible for the policies that they develop in their organization should look closely. I try to imagine myself as a head of an HTM program, and my boss somewhere up in the VP level comes down and says, I just heard this this Justin's YouTube thing where it said we don't really need to be doing routine electrical safety testing. It says, well, we're not doing that, right? And if I had to say, yes, we are, because I
Right
don't,
into the
I'm
policy.
scared.
Yep.
I'm scared. I don't want to have that conversation. So I think it's incumbent on us who write the policies for our companies to think hard about, where we spend our time.
That's interesting. I've got a couple other questions that came in. Um, do you have an example of a double insulated device that actually leaked? And I can't think of any time in my career I've seen anything like that, unless it's like a patient attached part or something that you already
Yeah.
talked about the catheter. You ever hear that?
Now, it's a good thing to bring up because there's a difference between something that is officially double insulated versus it just doesn't have a ground pin.
Right.
So, and you can look on that power plug and it will have a symbol. It's like a square inside another square. And it's because that thing is built with some extra layers of electrical insulation inside that makes it safer in terms of leakage current. So basically, you can't test a genuinely double insulated device. You can't test it, and they're okay to use in the patient care vicinity, but there's nothing to test in terms
Correct.
of electrical safety.
Absolutely. And let's see, I've got a question that came in from Kevin that says, this may have already been asked, but what about routine ground impedance checks? It's been our experience that this is the only time we found electrical safety failures with modern medical equipment.
Yeah, yeah, I know Kevin. He's up in Yellowknife in the Northwest Territories, and
Okay.
is very good at dealing with an environment where you got to stand on your own a lot of times, even now when it's still winter up there. So yeah, I have heard that, and the NFPA 99 doesn't address that. They would still say that's not required. I think if you see that, that's an example of where you might want to implement it in your organization. If I have evidence, I will do it, because I follow the data. What I've found is that when you dig into it a little bit more, you find that good visual inspection catches a lot of those things. So it's power cords that have their strain relief broken loose, or there's a cut in the wire, or somebody rolled the card over the cord, or the ground pin is bent, and I don't know. I have been a proponent of, rattle that plug up against your ear and see if you hear something rattling inside. So a lot of times you can catch those problems without a formal electrical safety test. But I would not argue against doing that if you found that that's a significant problem in your organization.
That's interesting. You brought up the plugs. I've been to several hospitals around Houston here where they don't allow people to put on the like the Hubble brand plugs. They you have to use a formally certified like molded cord. There's no plug ends allowed, and that I don't, I've been able to do plug ends my entire career. What do you think about that?
Hmm. So here's Matt's opinion. This is not a code issue. You I have seen I don't doubt that you do it right, Justin, but I've seen lots of people, lots of times that somebody did it wrong
Correct?
and created a problem by doing that. So
Yeah, we talked
my
about reverse polarity earlier, and that would be one of the only instances where people just they think the conductors can go in any order, right?
I've seen people who tin the wires before they put them in, which is a code violation. I've
Yep.
seen people that they don't twist twist the strands together, and so they have a few extra strands that are hanging out. I've seen some plugs that melted because they did a bad connection. It was a high resistance, and there was
Seen
I
it too.
squared R heating there. So my tendency is to say just buy a new cord set, but that's not a code issue,
Mm.
and if it's done right, it's fine. So I think that's up to each organization to have some policy on that.
Interesting. Yeah, that's definitely one of the things, as I talked about earlier, about core competencies. And to me, that's something that any biomed should know is the correct way to put on, cord ends and whatnot. Because to me, you never know what's going to happen in the field. I've had portable X-rays and stuff. The cord gets sheared off, but they still need to use it. I mean, I've had obviously doing operating rooms for years. Stuff happens, and when it happens, like we have to be able to respond quickly. And I'm pretty firm that people need to know how to do it correctly, even if it's not part of your policy in your hospital. You should still know how to put it on a cord end. It's part of your craft. It's part of what it is we do.
I
But
I won't argue against that.
well, Matt, I thank you so much for your time, and this has been absolutely awesome. I hope you guys have been able to get a lot of your questions answered. And if oh, I have one more question. Hold on. They always, when I start tying up, I get questions coming in. It, can you comment on isolation transformers, cath labs, and checking for ground loops? Wow, that's a good one.
Trying to sort that out.
Okay. Well, I know the
Ca-
only
ca-
time that I've seen ground loops is when they have like equipment carts and they have like carts plugged into each other. And I've seen like, ground loops happen that way. But
Yeah.
uh,
Well, the ones that I've been involved with, it ends up being because the the wiring behind the wall was not well done, and so there were
okay.
things that were supposed to be the same ground, were supposed to be ground at two different outlets, were actually a little bit different in terms of their resistance and the voltage level
Yep.
that they were sitting at, and so you can get some interactions between those. That's really a case by case basis. I don't know of a standard process, a standard test for that, but you would notice it in interference, I think,
Yep. And that's where
primarily.
I've seen it is actually on ECG trace on a pediatric during a heart case when it's supposed to be cardioplegia.
Yeah,
That's they actually seen the ripples, and that makes surgeons really nervous when they start to see activity. But
yeah.
that's the only
Uh,
time I've ever seen it. And believe it or not, the only solution was on the Livanova uh, heart lung machine. You know how the blood comes in, there's a temperature probe. They actually attached a ground directly to the metal temperature probe that is down in the blood.
hmm,
And so that means that they're connecting the patient bloodstream directly to earth ground, which is wild. I mean, no
yeah,
mega ohm resistor or anything. It's just they connect it straight up.
yeah. I think some people sort of just stick grounds here and there thinking it's
Yeah,
going to help. They may have been chasing an interference problem. They're trying to avoid that as well. So all I can say is that if you see interference problems, particularly in monitoring situations, um, consider ground loops. I don't think it's something you test for routinely
right.
necessarily, but
Correct.
it's something to think about for troubleshooting.
Well, Matt, again, thank you so much for your time. And you do offer a consultation business, which is amazing because if there are companies that would like more information, you can either reference the electrical safety manual. I'll have a link down below, like I said earlier, or Matt, you can go ahead and reach out to him on LinkedIn. That's how I talk to him. And I'll get your contact info if that's okay. And
Yeah.
if anybody has any consultation questions, then you can reach out to the expert himself.
Yeah, yeah. Anybody's got any short questions, that I can just give you a quick answer, don't hesitate to get in touch with me. And we'll look for maybe we'll do this again, Justin.
I absolutely look forward to it. Thank you, sir, very much for your time. Thank you all to everyone that's watching. We got greetings from Germany, and it looks like it is time. So thank you, sir. And I will stay in contact with you because I've got some crazy ideas that I've already started writing down that I would like to follow up on.
All right.